Okay, hello everyone, and welcome to another live stream with another amazing set of folks. My name is Sayam Pathak, and I'm a CNCF ambassador working as Director of Technical Evangelism at CIVO. And we are live again with another awesome session. And this time it's basically on cloud native chaos paradigms, and it'll be interesting because it's a kind of journey that we'll be talking about the chaos terminologies that have come up, the chaos cloud native chaos stuff that has come up, so how it has come up, what it is, then how Litmus has evolved from 1.x to 2.x, what was the need to do that, and then some of the demonstrations of the new set of features, how we can also discuss, like, depending on the interactions. Definitely you can ask about use cases. We can talk about the community aspect, how you can get involved in the chaos engineering space and especially contribute to the Litmus, because today's world, it's all about contributing and making the project better. And I think the open source community and the cloud native community is the best when it comes to helping out and doing this stuff. So that would be really great. So keep coming with your questions. Drop in, say hi, that you are there in the and listening. So that is good, and keep sharing on Twitter. So whatever your learnings are, keep sharing the thread. I always feel very happy going back, reading what we discussed, what went well, and what all things we have learned from the stream. That is important because we are here to learn. We are spending the next 1 hour learning something new, and that's the whole point, that's the whole agenda. And you also get to meet the maintainers, you also get to meet the people. Prithvi is there from the community, Karthik is the maintainer, I am there, I am the kind of end user. So basically you get the flavor of everything. So mostly it works this way, and that's where we kind of learn in all directions. And I try to put my perspective, and then I ask some of my own questions, some random ones and some quite calculated ones. So that would be always there. So I see people have been joining. So hello, and everybody just drop in and keep sharing in Twitter threads what you are learning, and make sure you subscribe to the channel. So it's already, I think, 5.2 or 5.1K, something like that is there, which is great. I didn't imagine that number when I was first starting, and it's good, going good. So I'm happy. So let's keep it going that way, so that we can reach the 10K mark by the end of the year. Kind of realistic, I'm not saying 10K just after the stream. So we have to be realistic. So it's 10K mark by the end of the year. That's the goal that I'm aiming for. Rest, it's up to the community, but I'll be keep bringing new content. You can already see the upcoming live streams. They are awesome, and you'll get a lot of learning. And there's a special kind of week that will be coming in November, around 2nd or 3rd, which will be again, just like we did the Knative series and the WSL series. So it will be another that sort of week, which will be very interesting. So I'm just finalizing, I think, one talk. So once that is done, then I can announce that. With that, today we'll be discussing all about chaos engineering and all about Litmus and where the chaos engineering community is headed to, some of the initiatives that are going on, some of the initiatives that you can take part in. Very warm welcome to Karthik and Prithvi. I know them very well. I have worked with those folks very closely, in different areas, and very happy to see them on the stream. So welcome, Karthik and Prithvi. Please introduce yourself to the community.
Thanks, Sayam. I think it's wonderful being this stream. Um, Thank you for having us today. Once again, I'm Karthik. I'm one of the maintainers of the Litmus open source project, Litmus Chaos project. It's a CNCF sandbox project. I also happen to work at Chaos Native, and very glad to discuss cloud native chaos engineering, how the project evolved, what we're looking at, how the chaos engineering community is generally. Looking forward to a very interactive and fun session.
Hello everyone. This is Prithvi here. You folks might have seen me here and there in some streams, and it's Great to be joining this stream with Siam. He's been a great community member. I work as a community lead for the Litmus Chaos project and also part of the Chaos Native team driving chaos engineering adoption and chaos engineering knowledge here and there. So looking forward to the session as well. Thanks, everyone.
Awesome. So let's get started. We have given enough time, 4 to 5 minutes, for the people to join. So who have joined, stay there till the end, and we learn a lot of great stuff. And those who'll be watching later, thumbs up to you as well. Make sure you like the video and subscribe to the channel. That is kind of I forget to say so, but whenever I remember, I'll say that. Karthik or Prithvi, whosoever wants to go first, like I want to ask, let's start with like the basic, the base definition of chaos engineering, because I think that's to set the right context. We should define it, not very deep, because there are a couple of videos already on my channel that explains, even CNCF minutes video that explain chaos, chaos mesh, litmus, and very well with respect to the chaos engineering as well. But to set the context, like how you define chaos engineering.
Yeah, like you said, there's in fact tons of information on the internet about chaos engineering. It's been there for some time, and now there's a huge explosion of data over the last 2-3 years. You have some very good uh, meetings that you've had with the chaos community, which are all available publicly, so you can learn a lot. To summarize, I think chaos engineering is like vaccination. I think that's a very popular line that's going around these days. So, and it's also reflective of the times that we're in. And it is basically injecting building immunity by injecting harm. You go ahead and do random failures on your deployment environments. You see how your system is behaving. If you see that there's something amiss, you go back and fix things. So this randomized, unpredictable injection of harm into your production or pre-prod or test environments is what chaos engineering is all about. And eventually, it prepares you for a better experience in production. Sometimes failures cannot be avoided. Even the best of organizations will still have some outages. You saw what happened with Facebook quite recently. But chaos engineering prepares you also to deal with these kind of outages. There's a mental model that gets built up. There's a company incident response culture that gets built up. There's a very good playbook that gets created on how to deal with incidents, how to root cause them, how to do blameless postmortems, how to ensure that you're better equipped next time an outage happens, and also, of course, to avoid such outages, you take back learnings, improve your chaos experimentation process. That's all. That is what chaos engineering is all about.
Cool. I think that's very good kind of introduction, because we are kind of injecting failures into the system, and then that gives us a sense how bad it will fail, and then we can fix it in certain way, or we can at least set up a process in a certain way, that if something like this happens, then what can be the ABC of the working. And you very rightly said, the blameless postmortems, those are very important, because things will go wrong eventually, not today, then tomorrow, or day after tomorrow. So it's just a matter of time when things go wrong, like Facebook. So eventually, nobody thought, right? Who will think, like, a billions of people using a product, and suddenly it goes out black 6 hours straight, and all the services. So things can go wrong, and they will. It's just a matter of time. We just have to be prepared. And chaos engineering has evolved in certain way, that it is building a culture within the organization to respond quickly, to respond in a certain way. Sometimes it's in a technical way, sometimes it's a process. So that's where it is. So now, how does the cloud native chaos engineering comes into play, and where does, how does it fit with the Kubernetes thing, the cloud native chaos engineering?
Yeah, it's a great question. So this subcategory, as we would like to call it, of cloud native chaos engineering today is something that's happened quite recently. So chaos engineering as a practice has been around, like Saim said, for quite some time. In fact, a little over a decade. 2010 or 2011 is when the first big video, or rather the presentation around chaos engineering, came from some folks in Netflix and Amazon. can actually trace the history back on YouTube. It's been there for some time. There have been proponents of chaos engineering like Netflix, Amazon, Salesforce. These were the pioneers. They've put together the principles of chaos. You can find that a single page website backed by a GitHub repository. It's called principlesofchaos.org, where you will find all the tenets or philosophy associated with chaos engineering. Now that is being practiced. In fact, a lot of mature organizations or organizations in mature stages of product development have been practicing chaos engineering. And it is typically the SREs, the ops folks that are taking care of or were taking care of chaos for a long time. But what happened in the last 2-3 years is this new paradigm of cloud native way of doing things. The entire microservices culture, the move to containerization, and the move to get containers orchestrated by Kubernetes, the de facto orchestration engine today, has changed a lot of things. It has changed things technically. It has changed things, like Sadim said, process-wise, the way people are looking at building applications, deploying them, testing them, maintaining them. There's a huge shift in a lot of these things. A lot of organizations have had to re-architect their applications, change the way in which the entire stack was built, decouple the main components or working parts of their system, convert them into microservices, Dockerize or containerize them, then run it on Kubernetes, then shift versions in Kubernetes, introduce policies. Basically, the Kubernetes journey, evolution journey that people are going through today has made people want to do chaos engineering a little differently from how it was being done earlier. Now, the philosophy and the basic intent remains the same, the things that we addressed at the beginning of this call. But what has changed is the way it is practiced and the sort of markers or cornerstones of the disciplines has changed a little bit. Now, what used to happen earlier is applications were a big monolith, right? You had people doing a lot of intensive testing, and then it would go on to production after a prolonged period of testing. Now, with the cloud native approach of doing things, your microservices are getting shipped very fast, and there are different pieces that get shipped at different times, and there are upgrades happening onto your deployment environments. It could be either the main production or the production-like environments that you are maintaining called pre-prod or staging environments, which is typically a very shared multi-stakeholder kind of an environment with individual service owners, people trying to replicate the working of their service or their part of the stack in that environment and testing it. So there's a different group of people who's always trying to act on that staging setup. So you keep deploying into these staging environments very fast. That is one thing. The speed at which you deploy is really fast. So there is an incentive for you to test in these kind of environments as much as you would like to test it before in your typical QA environments. That is one change that has come about. The other change is the fact that the new deployment environment today, the new production or staging environment today, which is based on Kubernetes, has a lot of stuff that is not controlled by you or the main application development team. There's a considerable amount of third-party resources that are being pulled in to give that overall application delivery experience. So you have a lot of tools pulled in from the CNCF landscape. The landscape diagram is getting tinier by the day. You can see that it's becoming almost microscopic because there's that many tools getting into it. So you will see tooling from storage, for example, OpenEBS or Portworx or StorageOS or Ceph. You have things like observability frameworks. You might have Prometheus, Grafana, or you might have Dynatrace or Datadog, whatnot. You have stuff that is coming in as a service meshes for better visualization and control of service traffic. Istio, Linkerd. You have your core DNS or kube DNS kind of service discovery mechanisms. You have application dependencies. You have things like message queues, your RabbitMQ, Kafka, something you're running. You have a data pipeline running. Then you have your actual application stack. consisting of the backend services, the middleware, front-end user-facing services. You have so many components that are running, all of which are very integral to the smooth operations of your cluster. The SREs have a stake in how your cluster has to run, and they make use of all this tooling. And then you have your actual application services dependent upon all these services. So there's a lot of, you can say nearly 80% of what runs on your Kubernetes cluster is not something that you shipped. It's something that you're not controlling. So it's something that it's coming to you in your staging environment by default. Now, the resiliency of your application depends a lot on how these microservices perform as well. They are also running as microservices as pods. So you need to be testing a lot of how these behave. Maybe you want to bring down some observability components and see how your system is behaving, because that's also important to how you deliver your services. So chaos engineering is ever more important in this environment. So that's why this new category called cloud native chaos engineering. And it's basically trying to do chaos engineering in an environment where there is a lot of churn going on in your deployment environments, a lot of tools that you've taken from your cloud native ecosystem. And there are a few other aspects to it. I'm just basically trying to recollect top of mind as to what really forced this change into cloud native chaos engineering. I'll probably share my screen and talk about some other operational aspects of chaos engineering which are influenced by the cloud native paradigm. What we've talked about are some of them already, the way you culturally, how you do things, how your ecosystem is changed, the deployment models have changed. But there are also some day-to-day things that you do in a cloud native setting that also sort of influenced how chaos engineering is evolving. Let me take you through that in a second. I hope my screen is available. It's visible now.
Yep.
All right. So if you take a look at this slide, I just talked about different components being part of your deployment environment and the need to test what happens when they go down, apart from the need to test your own application services, right? So you see this pyramid. In fact, we've not talked about the platform components going down or the Kubernetes services going down. Kubernetes control plane might be impacted. If you're running a self-hosted Kubernetes, the nodes or the VMs that is actually serving your hosts or serving as the hosts of your cluster can go down, or some issues might develop within core components like storage on these nodes, or the network, the management or data networks of these nodes. So those are also things that you would like to test. So in these cards on the left-hand side of this slide, we basically say what we just talked about. And then there is this last card that you see at the bottom. This is what I was referring to when I said the day-to-day working in a cloud-native setting is slightly different. So you're basically trying to manage everything in a cloud-native setting in a declarative way. Your applications are defined declaratively. It's all stored in YAML files. You have Kubernetes resources defining how your application should run. And you're talking about security policies, you're talking about resource constraints, how much CPU memory, you're talking about the deployment parameters, you're talking about how quickly or how frequently you should deploy, or what are the sources for your objects, your resources on your cluster. So all that is defined in a declarative way. So an average Kubernetes developer, cloud native developer, application developer, or an SRE is dealing with things in a completely declarative way. They're storing everything in Git repositories. They have deployment controllers or GitOps controllers, as they would call it, which sync your source with your cluster. So this is the state of things. So when you talk about resilience checks, when you do all these things, lifecycle management, resource management, policy management, everything in terms of Kubernetes resources, you would like to do everything associated with the resilience in a similar way. The fault that you want to inject as part of a chaos experiment needs to be defined in a Kubernetes resource. It needs to be storable in the Git repository. The way that you sort of carry out the fault itself needs to be it basically needs to be in a reconciliatory mode, the way other Kubernetes resources work. You basically go make a change in your fault spec, and then you expect that the fault injection changes accordingly. And you also would like to do some steady state hypothesis validation in the same way. Let's say you injected a fault and you expect that this service should behave thus, or this should be your infra state, or maybe this recovery mechanism should kick in, or maybe this is the expectation you have around how quickly your fault or your down or your application or your service outage is reported in your observability system. This is how quickly it should recover. This is how quickly your self heal should actually work. So these are things you would like to validate as part of a chaos experiment. The chaos experiment is a combination of fault injection, steady state, hypothesis validation, the deviation in steady state, etc. This all combines to give you a chaos experiment. So all that validation also you would like to define in terms of resource. And that's when Kubernetes gives you this flexibility of custom resources. So you have CRDs to extend the core Kubernetes API. And chaos experiments today in the cloud native world are mostly defined as custom resources. You have controllers that carry out the chaos experiment business logic. So these are the characteristics of this subcategory called chaos, cloud native chaos engineering. Why it was needed and how it is done is what we've spoken about. And at this point, I just like to bring to notice where chaos engineering is in terms of crossing the chasm. So Kubernetes has crossed the chasm, and the cloud native chaos engineering, the philosophy is in the early adopter stage today. And there are some organizations, both vendors and end users, who sort of picked up this trend. And when I say vendors, I'm not just talking about the chaos engineering vendors, I'm talking about organizations that provide cloud native software products. You can say Red Hat or VMware, organizations like this who've actually picked up chaos engineering. And then there are a lot of end users that are also picking up this philosophy of cloud native chaos engineering, but it is still in the minority. It is becoming widespread. As you can see, there's a lot of advocacy going on around chaos engineering. You're seeing SIAM talking about it often. Chaos engineering featured in the keynote of the recently concluded KubeCon on the day 2 keynote. And it was also something that was referred to by the TOC in the previous edition of KubeCon, the one before the North America one that just ended, where the TOC chair said it's one of the 5 trending technologies or areas within the cloud native ecosystem. So it is picking up, but it is right now in the early adoption stage. It is yet to cross the chasm. That's the finding that we have as members of the chaos community. So with that, I hope that answered Sayam about what is the subcategory of cloud native chaos engineering and how organizations are looking at it.
Absolutely. I think it very well answered in detail, like, where in the pyramid actually it sits, and then how it has broken down into, applies to different cycles inside Kubernetes and in the market as well. And rightly mentioned, it has been mentioned a couple of times, more than that actually, during the keynotes and during, all the talks, and how important it is to kind of practice the chaos engineering culture and chaos engineering techniques, irrespective of the tool, but you should definitely follow the culture and build that practice within the organization, so that whenever, again repeating the same thing, whenever something goes wrong, you have something to fall back on, you have a plan to work on, and you don't blame, you don't, keep finding the blames to, who did this. That's not how the organizations operate these days. It's okay, it happened, it should not happen again, one. And what do we do? Two. That those are only the two things that we care about. So I think that's pretty neat way of introducing this. So now we are already seeing, the Litmus chaos stuff. Now tell us about Litmus chaos, how it is, how it is solving the cloud native challenges, cloud native chaos challenges, and in the Kubernetes ecosystem, in the CNCF ecosystem, and where we are today. Then we'll move from, I think, 1.x to where we are today.
Sure. So Litmus as a project was built to address this cloud native chaos engineering need. And you can see in this slide the flow of a standard chaos experiment. You will see that you typically start by identifying what is the steady state or the optimal operational characteristics of your app in a utopian condition. And then you go introduce a fault. You basically have a set of SLOs. Your SLOs are the high level constructs from which you derive steady state hypothesis for each part of your service. You verify whether those are met even despite introducing the fault. And if they continue to be met, then that's great. If there is a deviation that you're okay with, and you expect that things will get back to good state within this much time of injecting the fault, this is the self-heal that I'm talking about. You might have a certain expectation around it. If that is met, that is great. You're in the improvement path. But if you have found a weakness, or if your hypothesis is your MTTR, the mean time to recovery, is not good enough, that means you need to go back and fix something. It could be in the application business logic. It could be a deployment best practice that you missed, or maybe there's some tuning that you need to do in your underlying Kubernetes platform. It's maybe a Kubernetes variable. Maybe there is something that you need to do set on your OS, for example, things like that. Now, if you look at this slide, there are some custom resources, the Litmus custom resources stacked under the respective portion of this flow. So you can see the chaos engine and experiment CRs that define the fault and define how you run the experiment. There is an operator which reconciles these resources and carries out the business logic of fault injection and hypothesis validation through some runners. These are pods that run on your cluster that carry out the business logic of the experiment. And all this information is stored in a result. There's a question that we generally get asked. Why are there separate chaos resources or custom resources for these things? Why not combine them into one thing? That's one way of doing it, of course. The reason why we sort of separated it is because each of these aspects have scope for a lot of rich growth. That's something that we're talking about in this slide. The experiment CR is a low-level definition of your chaos parameter. It's pre-built. It's available as a template in a website called the Chaos Hub, which is an open marketplace or a catalog of experiments which you can use to pull experiment templates, fault templates, and install on your cluster. So this is basically the chaos experiment. Whenever you create experiments, whether they are off the shelf, retrieved from Litmus, or something that you build yourself, Litmus supports this concept of bring your own chaos, BYOC, as we like to call it, where you can define your own business logic, containerize it, and sort of get it orchestrated by Litmus. When you're defining what is your experiment about, what is the image that runs it, what are the permissions you need on the cluster in order to run this experiment, what are the libraries associated with it, all that is defined in the CR. Engine is something that is user defined. You probably deal with it on a day-by-day basis. It binds an instance of your application, your microservice on the cluster, or your infra component like a node or a cloud resource to a particular fault. And you also define steady state hypothesis inside this particular engine because it's an instance specific thing. Maybe your steady state validation changed on your run. Maybe it changed from environment to environment, service to service. So you need to have that flexibility and have the ability to define that on an instance basis. So you can do that here. You can override a lot of low-level tunables that you have in the chaos experiment, and you can define run characteristics. Maybe you require all third-party tooling, or you need all, for example, Litmus is a third-party tool for a lot of people in their environments. So you would like to learn these kind of tooling in a dedicated node. You would like to run it on nodes that have specific taints, or you basically want to use node selectors. You want to specify resources. Maybe you're operating in a shared environment with a lot of namespace scoped Litmus operators running, the people running experiments in parallel, and you want to be able to restrict how much resources that you give to each experiment run. You want to decide the service accounts with which these experiments can be run. Maybe there's an admin persona who is creating this beforehand and allocating it to developers to associate with their experiment runs. So all that is possible to do within Chaos Engine. And then you have a result which holds details about what happened during the experiment run, what happened to individual steady state validation constraints that you defined. Maybe you looked for some downstream applications availability. Maybe you looked for some deviation in a Prometheus metric that your app exposes. You're looking at some self-heal time. You will be looking at some orthogonal characteristics, like how much time did it take for an event to get generated. Things like that you basically hold information about in the chaos result, what happened to those constraints. And then you get a verdict based on all the constraints, what is the success criteria that you've set. And based on that success criteria, what is the verdict of this experiment? Because a lot of times you're running these experiments in an automated way. You're not peering into your observability systems when you run them. Maybe it's not a game day. Maybe it's something that you're running on your dev test cluster. You're setting up an automated run. So you need to know what happened. So you need the chaos results. And there's a lot of scope for improving what all the result holds, what all the engine holds, and what all the experiment holds. So that's why we have different CRs. And Siam talked about Litmus 1.x. I'll probably just go through very quickly on how we started this project, what we had in the beginning, and how it has evolved. And I'll just give you a very quick demo. There's a lot of resources for demos on the internet, and there's also a tutorial that we have on the document. There's a Katacoda scenario that you can try for both 1.x as well as 2.x. So I'll probably let Prithvi point you to those resources at the end of this talk, but I'll focus more on what we started with and how we evolved. And when we started Litmus,
Yeah, just before that, Karthik, there are a couple of questions.
Sure.
Maybe we can take that before diving into the architecture flow. One
Yeah.
is, when it comes to managed Kubernetes services, how relevant is chaos tools like Litmus?
It's a great question. Um, there are different ways in which managed services are consumed. We've seen this use case in the community. It could be a hybrid model where you're using managed Kubernetes, maybe something like GKE, EKS, AKS, things like that. You still need to test out how your microservices behave when some failures happen within your pods, for example, or when your node is terminated. You might have auto-scaling setup. You might have a lot of self-heal mechanisms provided to you by managed services, but you still need to check how well they work. And I'll point you to a use case. For example, let me just very quickly show you the example of a Kafka deployment, let's say in a managed cluster, for example. So you're deploying a multi-replica stateful set of Kafka, and you've basically identified the leader brokers for some of the partitions, and then you've killed it. Typically, it has there's a failover that occurs. There's another partition that can become leader. Or if you happen to kill a broker that's also the controller broker, the leader broker, then there's going to be a re-election. So depending on that, your IO might get timed out, your messages might get timed out to the consumer, or they might work, right? So these are things, and the timeouts that you have probably might need to be tuned depending upon the storage that you're using for these brokers, maybe the CNI that you're using. There are a lot of factors that are at play, even in these kind of environments, which you would do well to test out. In the experiment that we're showing here, it's actually a simple pod delete. And Kubernetes actually brings up pods if it's a stateful set or if it's a deployment. But there are other dynamics at play. If you're using some complex systems like Postgres or something which has a leader follower model, maybe you have a multi-master setup which probably does synchronous replication. Things like that, you would still want to see how it behaves for certain failures. This is one kind of managed services, but I also suspect that you're talking about the cases where you don't really have access to infrastructure as per se, but it's all in the cloud. You're using, say, Azure App Services, for example, or you're using RDS on AWS. So if there are some systems, if you're running in a hybrid model where you have something running on Kubernetes that you can access, and then you're also consuming things from a managed service, then the boundaries of or the boundaries of interaction. Let's say your network might get compromised and may not be able to reach the app service, for example, or the SQL server that you're hosting on Azure might become too slow because there's a lot of IO happening against it. These are some things that you might still be able to do. And the cloud providers often, in most cases, provide you with very well-defined SDKs that you can leverage to do some chaos against the services running in managed services. You could do web app stop start, for example. You can play with firewall rules. You can play with what ports that you're using. You can make an HTTPS to HTTP, for example, see the behavior of what's happening. So these are things that you could still run as part of a chaos experiment, because you still want to see how your application behaves, responds, or recovers from these kinds of faults. Most managed services provide you with the 99.9995969 kind of availabilities, but there is still some scope for failures that you would do well to test out. So chaos engineering, I feel, is still relevant even in those environments.
Yep, and just to add on, like whenever you talk about the managed Kubernetes services, obviously they take care of the master and the availability of your cluster, but they do not take care of the applications you run on them. So your applications and how they will be behaving, the pods, how Kubernetes itself will be, whenever your pod goes down, or if it's too much of traffic, or auto scaling of the pods, horizontal pod auto scaler. There is one chaos experiment related to that. So all those can be used as part of your chaos experiments. So there are not as infrastructure experiments, you get limited to that in some way, but there are other set of experiments that work kind of in the same way when you are running even your own unmanaged cluster. There's another one
Let's say,
from
yeah, there's
yeah,
just a small follow-up thought to the previous question
mm,
based on what you were saying, Sam. So, for example, you've set up smart auto scaling, or you've set up some auto repair, auto upgrades on your managed services. Kubernetes upgrades can be sometimes very disruptive. You've just not braced for some new changes that are coming in a newer version. So those kind of things are still you need to guard against and probably experiment with in your staging environments. You might be having a lot of load, and suddenly your autoscaler goes crazy and spawns a lot of pods, and each pod is configured with a resource request, and that basically makes your node autoscaler go create new nodes, and then at some point you're going to scale down. So this is also chaos at some level. There might be technical impacts because of this. There might be other operational impacts, cost impacts, and things like that because of this, which also sort of fall under the purview of the broader chaos engineering agenda. So it's something that you would do well to practice even in managed environments.
cool. And another one is from my friend Sid. So basically, he runs the YouTube channel called DevOps Directive. I mean, you probably might have heard of that. How
Yeah.
awesome stuff he does. Make sure to check that out. So he's asking from the previous slide, I believe, is all the info stored in the CRDs, or does Litmus use additional data store for persistence?
Yeah, it's a great question. We're sort of coming to that. So as far as the experiment run goes, it's all in the CRDs, but you could probably only hold so many resources. You might want to do purges of these resources from time to time. You need also to be able to compare the results of your run that you've been doing over a period of time. You're doing chaos for a long time, maybe you upgraded to a new release and did chaos, and you want to compare what happened with the previous run to this run. So there is a use case and definite need for being able to store all of this in a dedicated data store and doing some kind of analytics over it. In fact, that's one of the reasons why so that was one of our driving factors to move or consider when we went to 2.x. It's there in a couple of slides from now, so I'll definitely get to that.
Awesome. Okay, let's move on to the quick architecture explanation of 1.x.
Sure. So when you started 1.x, it was very simple. There's a declarative definition, there's a CRD, you have an operator which you installed via Helm or Manifest. You pulled your experiment templates from the Chaos Hub. The Chaos Hub looks like this. You can visit hub.litmuschaos.io. Some description about faults, and you can just pull these templates into your cluster. And then you can create the chaos engine, and that is what is watched by the operator. It spawns off some jobs, does the fault, and you're done. There's information stored in the chaos result about how the job went. That's what we had in Litmus 1.x for a long time. It did meet the chaos fault injection needs, the ability to do failures, right? But chaos engineering is not just limited to that. It has evolved, and a lot of other aspects to a chaos engineering practice. So this is the main motivations for us to actually move to 2.x. One of the things was visualizing impact of chaos. Now, you basically need to know what is happening in the experiment. Maybe running a long-running experiment, which has multiple steps, multiple faults also, and you're doing it against different services. You want to really visualize what's happening at what time, right? And you want to be able to analyze maybe build over build, release over release, or environment versus environment as to how a particular experiment performed. And if you want to compare, you need a basis for comparison. You need a parameter against which you can compare. So what is this parameter? And using this parameter, how do you connect your use case and your service? You have a service, and then you have a fault against it. You have a chaos scenario against it, and then you need a way to bridge this particular service and use case with a score. So for this particular service, for this use case, this is my score, and this is how the score is changing across runs or across environments. There was a need for us to do that. So that's when we brought up the concept of a resiliency score. And we also brought in the concept of workflow. You're seeing this third point here, which said you need to do more complex scenarios, because misfortune, when it happens in, it doesn't happen singly. So you have, for example, visualize environment where you have most of the nodes running to full capacity, and then you had a lot of load coming into your system, and then you have one of the pods getting evicted from one of the nodes, or you basically went and had a crash in one of the services. So it needs to get rescheduled, but you really don't have a successful reschedule because most of the nodes are running to capacity, or it might take a long time. It might stay in pending state for a long time, identify which node is the best, and then go schedule there, during which time there might be IO failures, or there might be some message failures that happen. Your communication might break, your timeouts might be breached. It's also possible, especially when you're using stateful workloads, when you move from one node to the other, your PV has to get reconnected to the new nodes. And in a lot of storage systems, that takes time. You probably have to remount your file systems and then sort of instantiate your applications. Your applications might have a lot of startup procedures. They might have readiness probes with high initial delay periods and complex logic before they are called ready. So the impact of things like pod deletions or node failures is much more in these kind of cases. So you want to simulate that scenario, get your nodes running to capacity, and then cause a failure. Right? These are all complex scenarios that you would like to do in some order, maybe in sequence, maybe in parallel. That's when we brought in chaos workflows. And then we introduced a concept called probes, which basically help you to do validation. Things like you verify whether the particular custom resource that is managing your application has this field set. A lot of people are using CRs to manage their applications. You have operators for everything, especially stateful applications. You have a lot of interesting fields in those CRs which actually tell you the health of your application. Maybe as part of an automated run, you want to verify that field. Maybe you want to run a database integrity check by running a CLI utility. Maybe you want to consume Prometheus metrics and see how your application metrics have changed, how your performance is doing, how your latency parameters are changing, whether they are within the thresholds. You might want to check something like there's a downstream application, a HTTP GET or a POST call to that. Is it working and giving me the right result? So these are things you want to validate as part of your application to run. So that's something that we have enabled using probes. And we also wanted to basically, this is all related to the experimentation process. And I'll show you how the Chaos Center UI allows you to do all that. And also some screenshots and some sample definitions. There are other operations challenges. Now, chaos engineering is spreading in importance, and its value is getting more recognized. So there are multiple teams, multiple departments in your organization who are doing chaos engineering against their own environments and their own clusters or namespaces. So you don't want to be going and installing Litmus or installing the chaos control plane in every cluster or namespace that you're working on. You want a centralized location, and you want people to collaborate, exchange artifacts, exchange results. You may have different personas. Maybe there's some kind of a CIO or a lead kind of a role who is actually looking at how things went over a period of time, right? Who's not actually actively executing chaos. It's something like a viewer persona. There's a persona who's actually constructing new scenarios, building new workflows. Then there's someone who's actually automating when it should be run. There are different kinds of personas in a team that's running chaos. So you need to be able to enable teams, get all these personas together in one platform, give them the right permissions, get them to successfully operate. That's something we took on board and created. There's also the need for you to be able to manage your chaos artifacts. You need a single source of truth. So we've enabled some GitOps functionality where whenever you construct workflows on your chaos center, which is a single pane of glass management tool for your chaos, it actually helps you to pick faults from the chaos hub and construct workflows on the dashboard or via API. When you do that, you can actually commit those workflows into a Git repository, store a golden copy there, and ensure that you are able to actually successfully make changes into that Git repository, into your source, and that gets reflected on your chaos center, so that the next iteration of this workflow carries the new definition that you've given. So this is something that we've enabled to simplify storage of your chaos artifacts, because your workflows are essentially scenarios, maybe test cases. So you need a management system for that. And then the next thing is about how you operate in air-gapped environments. You basically have a private Git repositories. You have your own image registries. So how do you simplify operations in those environments? The ability to do bulk changes on your artifacts, replace images from different registries, pick experiments from different sources. You may be configuring private repos with access tokens or SSH keys, things like that. Those are some of the things we took on board as well. And then people want to construct their own experiments. You can provide 100 faults, but people want their own custom experiments, which probably leverages your fault, takes business logic from there, but also adds their own custom logic, their own validations, things that they tailor to their own environments. So provide some kind of an SDK, some kind of a bootstrapping or a scaffolding tool that helps people generate their own experiment business logic, while maintaining a homogeneous structure as with the rest of the Litmus experiments. A Litmus experiment has a definite structure. There's a pre-chaos check, there's a chaos injection step, there's a post-chaos check, there are events created at each stage, Kubernetes events generated at each stage, things like that. So people would want to take these best practices and construct similarly, but with their own logic, with their own fault injection and validation logic. So help them with by providing some tooling, some SDK to create their own experiments. So these are things we took on board and created Litmus 2.0, which is basically what this is. So you have different environments, different target clusters or namespaces that you can register into your chaos portal. And you also have Prometheus metrics. There's a chaos exporter that helps you to get Prometheus metrics for chaos. When chaos started, when it ended, how many past failed experiments are there, what is the probe success percentage, all that information is available. So you can have a centralized control plane and manage chaos across a fleet of clusters. And there's another requirement that we got. How can you do chaos against non-Kubernetes resources? I want to bring down EC2 instance or an Azure VM that belongs to a scale set. How do I remove a GPD, a Google Persistent Disk, from a node and then reattach it later? How do I take down an Azure app service, maybe stop it from functioning? Things like that. All this is possible through the SDK, like I said, provided by this cloud platform. So we can create experiments that run inside Kubernetes, but access the cloud resources over the network using API, and then cause faults against them. So this is a new category of experiments that we've started. Similar story with bare metal, where you probably leverage IPMI or SSH to cause these faults. And this is the overall architecture. You have a control plane. The chaos center is part of it. There's a GraphQL server. There's a front end. Then there's an execution plane, which is where all your action happens. So it's consisting of some agents that speak to your control plane, the servers sitting inside the control plane to receive instructions about what faults to run, what workflows to run. And then you have the erstwhile 1.x components, the core backend components, the operators and exporters and CRDs sitting inside here. And your workflow basically is set of CRs or a set of steps defining what faults you want to do when and how. And the chaos operator actually runs the fault associated with these CRs. The workflow basically creates these CRs, and the operator picks these CRs and carries out the business logic. This entire information is sent back, relayed back to your chaos center, and it's stored in MongoDB. That's the data store that we have. Then you can have workflow runs that you have over a period of time and get resiliency scores against it. So at this point, let me take you to how a chaos center looks. So you can actually log out. Let me start from the beginning. You have admin credentials by default. So you can log in, and you have a default set of credentials. Once you're logged in, you will have a project that you will work with. It's a workspace, a logical workspace for you to operate in. And you have agents connected here. There is a self agent which is auto-magically registered. So this is basically the same cluster where you have installed your chaos center. Or if you're installing this whole thing in namespaced mode, which it also supports, the self agent is basically going to help you do chaos in that namespace. Or in clustered mode, it's going to help you do chaos in that cluster. It's by default going to lend itself to chaos. Or you could also connect external agents. So you have something called Litmus CTL, which is a very interesting CLI tool. And you can actually leverage that to go ahead and add new clusters. When you add a new cluster, your what do you call procedure is going to be something like this. You will have a couple of steps. You do a config set account by providing the endpoint of your chaos center along with your admin credentials or user credentials, as the case may be. The admin can add users with a non-admin persona who have their own clusters that they can bring. And you can do a Litmus CTL create agent, and it will basically help you to do a set of things. What is the project that you want to subscribe to? What is the scope of operations in this cluster where you are installing the agents? Whether you want namespace or cluster access, and what is the name, what is the description, things like that. You can give some name, you can give some description, and then you basically say, how do you want to install these agent components? Do you want them in a specific node, things like that? And then finally, what is the environment that you're installing it against? And then you basically say what namespace you put things into, things like that. And then you finally get a manifest, which is auto-generated and installed. And you will end up with a set of pods. So I have got something installed already. You can see these are the control plane pods, and the rest of them correspond to the execution plane pods. Subscriber is the agent, the workflow controller implements the workflow steps, the operator reconciles the chaos CRs and carries out the business logic of faults. The exporter provides metrics. Event tracker is basically an ability, it provides you with the ability to subscribe to a particular workflow. And whenever you have changes happening to your application on your cluster, either through Flux or Argo CD or anything, it actually goes and triggers the workflow to which this app has subscribed, thereby providing you with some kind of a sanity check. So these are all the things that you will find. And now this agent is active. You can actually go ahead and see what applications reside on that cluster. You can do a discovery. You can basically go ahead and construct a new workflow. And as part of the workflow construction, you will be able to see what all experiments are there on the hub. For example, I've got a different cluster here, which I've already used. So you can see when I construct a workflow, I can select the agent and I can basically use a pre-existing template from a Git repository, or I can create a workflow by uploading it from my workspace, my laptop. There's a YAML definition that I might have, so I can go select some workflow manifests, or I can construct something completely newly by selecting things from my Chaos Hub. I can go ahead and pick some experiments that I have on the embedded Chaos Hub inside. So I can go and select what experiment I want. I can go ahead and tune it. I can also see as part of the tuning what namespaces reside on this particular cluster and what kinds of application I want to do chaos against. What are the labels that to filter amongst these application types, and what are the experiments, what are the steady state validation probes that I can add, what is the other tunables that I would like to add into this experiment, and then finish it, and then carry out chaos. And once you've run this experiment, you will see the flow of the experiment. This is what we talked about as visualizing the stages of chaos. And you can see the failures and success and the logs of the experiment and results of the experiment, all that is available. So you will be able to fetch the logs and results provided you have the resources available on the cluster. If you want to, this is dynamically fetched, but you can also see the results stored in your analytics section. There's something called observability, where you can actually see the results stored for posterity. You can also run some checks against it. You can do some resilience score comparisons, download reports, and also do some monitoring by connecting data sources like Prometheus. So whatever you do on, let's say, a Grafana dashboard is something you can also do within Litmus. You have your own Plotly-based dashboards that you can construct here and have a single place from where you monitor stuff. So there are other settings you can do, like I said, invite team members with different roles for users, and you can create new users, assign a specific role to them when pulling them into your team, configure Git repositories into which you want to store your chaos artifacts, etc. So these are the various options that you can perform with Litmus 2.2. There are detailed demonstrations of workflow runs, how you can construct new workflows that we'll be happy to share on another call or probably provide links to. I just wanted to take more time in explaining what approach Litmus has taken to chaos engineering, why we made the changes that we did, and eventually how the platform looks like. So you get a good idea and good context before you actually try out by looking at the documentation. There's also these interleaved graphs that I talked about. If you look at this particular YAML definition, you can actually see how we've defined the probes. So these are the queries, that prompt queries that we're performing. This is the criteria that we are checking. This is one example of how you define probes. And you can also see how you can annotate Grafana dashboards. You can basically see the period when the chaos is active. See those dotted lines, and this red area on your Grafana dashboards is actually telling you when the chaos is active, when it's ended. You can actually see what happened during that period with your applications. So this is all coming from the chaos exporter metrics, and that's something that you can see within your portal as well in the observability section that I just talked about. So these are the capabilities that we are working on. And in terms of future, what we're planning to do going ahead, there are some interesting features that are coming up. You can take a look at that in the roadmap section. We're trying to add more experiments for non-Kubernetes. We're trying to add newer chaos types within Kubernetes, and their improved scaffolding capabilities. And we're also trying to look at improving the security part of the chaos center. There's a detailed documentation around the security considerations in Litmus that we're happy to provide in case you're interested. What are the different tools or plugins that we have, or what are the care that the developers or admins need to take while leveraging Litmus for doing chaos experimentation in production environments. And we're also looking at curating special interest groups for the project. This is basically a set of like-minded people who are interested in various aspects of chaos engineering, maybe observability, maybe integration into CI/CD, maybe about integrations with security tooling, things like that. People who are doing, people who are interested in adding more orchestration capabilities, things like that. So we are asking for people to come forward and register your interest. We'll probably go ahead and start some focused meetings on these aspects of the project. And we already have a couple of operational SIGs for observability and for documentation. Documentation is a huge thing for any open source project. We had people who signed up to learn the area or the project by contributing to documentation. So we have that happening every week. So if you're interested, please let us know. We'll be happy to onboard you and get you as part of these SIGs. With that, I'll probably stop and I'll probably take some questions and let Prithvi talk about the community aspects of Litmus Chaos.
Sure. Before, perhaps if we have any questions or perhaps Sayam wants to ask something, I'll just quickly go through the community aspects, and then we can wind up. Just give me a sec. So I hope my screen is visible. I'll just talk a little bit about the project history or the project stats and how the community has grown. Obviously, this project started way back in late 2017, 2018 to test OpenEBS. OpenEBS is another cloud native project, a CNCF project, sandbox project based on cloud native data, and that is how Litmus was born, basically. And since then, it has come a long way, where today we have seen 50 plus chaos experiments and so many experiment runs and 2.3 million Docker pulls, and the community is growing. 1,000 plus community members. It's rare to see any CNCF project or a chaos engineering project reach 1,000 plus community members. And initially, when I started off or I joined the project or the community, it was just a community of 100 plus 150 plus folks, and obviously folks have been reluctant about adopting chaos, or the practice is not there still. A lot of people are not aware of how chaos engineering is practiced, what are the business SLOs to be followed, or how basically that can be brought into the roadmap. The budget is not there. There are a lot of uh, you know uh, there are a lot of reasons why chaos engineering is not yet adopted, or roadblocks that come into place in an enterprise or in any sort of a team. But that is how chaos engineering has grown, and today resiliency and reliability has been something which has been catered to or looked at very importantly. Even CNCF predicted that 2021 will be a year where chaos engineering will be looked at, and it's been true. And with the feature at KubeCon and how chaos engineering is developing, chaos engineering has already reached the majority adoption chasm as spoken by InfoCube. But if you talk about cloud native chaos or open source chaos engineering, there are obviously milestones to cover. But with the project growing and with contributions coming in, I think the project or the integrations are all about the contributions that have come from the community and how the community has seen the project with the various use cases. There are so many different paradigms where chaos engineering can be used. There are so many different sectors. You talk about e-commerce, you talk about airlines, banking. Each and every sector has different requirements, different use cases of chaos engineering, and that is how it has grown and it is coming up. I think a talk basically on the community and the culture can be a different one altogether. But I'll just come to the contributing part. There are a lot of good first issues. We were going through Oktoberfest, the last week of Oktoberfest now, and there are a lot of issues that were created by the maintainers, core contributors, as well as community members. So all kind of contributions are welcome. You can obviously come in and contribute a chaos experiment, most importantly, and I can help you with some swags as well in case there are some good contributions. But other than that, obviously you can contribute a bug fix, an enhancement of or some improvement. As Karthik mentioned, that documentation is one of the most important aspects of an open source project. So more contributions to the documentation, coming up with more tutorials for specific applications. We already have tutorials or use cases for, let's say, a sock shop application or a potato head or a bank of anthos application. But chaos engineering can be used with a lot of applications that are out there, or there are so many adoption stories or use cases that can come forward as contributions as well. So there are some sub-dependent repos that you can contribute to: the chaos charts, chaos workflows, the Litmus UI, the Litmus Core repo. I mean, we did not talk about this aspect, but I mean, you can contribute your experiment, or you can write your own experiment with the Litmus SDK, which can be written in Go, Python, or Ansible, and you can run it with Litmus, which obviously makes your chaos engineering journey easier. And lastly, the website, of course, to just help the community grow and help the community get access to some more resources. And these are some important links. I'll just share how you can join the Slack, but here's the code. I mean, you can find it on the GitHub. I think Sam already shared the link of the docs as well. The version 1 docs obviously help you get access to 1.x docs. And lastly, to join the Slack channel, if you are on the Kubernetes Slack, you can just join the hashtag Litmus channel, or you can just join Kubernetes Slack using slack.ktest.io and then use slack.litmuschaos.io or join the Litmus channel directly. So thank you. With this, I think we come to the end of the presentation we have, and thanks Karthik for going about the demo and the overall talk. So with this, perhaps we can just take any questions, or Sayam can just write
Yep.
down the slides.
Yeah, I think that's pretty neat. We covered. I have posted the kind of highlights that we covered today. So what chaos engineering is, what is cloud native chaos engineering, where it is headed to, and where Litmus 1.x came in to solve the problems, and where the Litmus team and the community itself, saw a lot of things that could have been improved. So it was a complete kind of redesign, and that's where the Litmus 2.x comes. So it is a kind of complete redesign. You have seen how the workflows are in, how the observability is into the picture. So how you can connect multiple clusters, teams, and tons of features are there. So we have seen that, not explored individually, but there are tons of features. I posted a GitHub repository where I did a KubeCon demo, and you can check that. It shows the power of annotations, the flux, the GitOps flow, and how any changes to the Git will trigger the chaos experiment. So all these things are there, and I have done that using 2.x past kind of 6-7 months back, when it was kind of releasing from beta to GA, around almost around that time. And then we listened a lot about the community aspects from Prithvi, how you can get involved and do a lot of stuff with the community. The last bit that I want to add is the chaos engineering working group. Yes, there is a chaos engineering working group on the CNCF cloud native community Slack channel that you can join, and you can be part of that. Community meetings are there. You it's The community meetings is getting involvement from different chaos projects like chaos mesh and other projects. So it's kind of a diverse group over there, and moving towards a goal to establish a white paper that can be prove very beneficial for beginners, end users, chaos projects, and building a kind of, not a foundation, but building a kind of structure, a process, a procedure, so that everybody can follow or adhere to the practices that are defined in the white paper. So make sure, if you are interested, join the Slack, get involved in the formation of the white paper. And apart from this, yeah, I really enjoyed the stream, because that was what I was looking for, actually. So you can I think the highlights are pretty clear. We have explored tons of stuff, and there are a lot of demos on Litmus 2.x done by Karthik, Prithvi, myself, and you can find a lot of stuff on YouTube, and talks at different different places everywhere. There is definitely everywhere there is one chaos engineering talk that will be there, and that's how it is today. So every cloud native conference, you'll definitely find something related to cross engineering. So that's where you should actually start practicing in your organizations, or you should start researching about some tools, or reach out to Prithvi and myself or Karthik for community involvement, get started, and do awesome stuff. So thank you, Prithvi and Karthik, for the amazing session. As always, we have sessions lined up. Make sure you subscribe to the channel and set the reminders for the upcoming streams. And thank you so much, both of you, for your time. And thanks to everyone who joined and who will be watching later. So with that, we'll close the stream. Thank you all. Have a nice day.
Th-
Bye.
Thank you. I think enjoyed
Thanks, everyone. Bye.
talking today. I hope you've gathered something useful through this. Thank you for having us once again. Have a great
Absolutely.
day. Cheers.
Bye.